On October 13th, 2025, something happened that has the astronomical community either scrambling for explanations or pretending they didn't see it. An interstellar visitor allegedly transmitted light pulses in a sequence that shouldn't exist naturally. 5, no 8, 13, the Fibonacci sequence, the mathematical fingerprint of creation itself, appearing in sunflower spirals and galaxy arms in nautilus shells and the proportions of the human body. And this occurred on the exact 108th anniversary of one of history's most witnessed, unexplained phenomena, the miracle of the sun at Fatima, Portugal, where tens of thousands watched the sky perform the impossible, while NASA's Solar Dynamics Observatory conveniently went offline for maintenance, while our best Mars imaging cameras mysteriously stopped working just days before the object's closest approach, while the object itself disappeared behind the sun, hidden from view for 6 critical weeks, during which it could do absolutely anything without us knowing. Right now, as you listen to these words, that object-designated 3I Atlas, the third confirmed interstellar visitor in human history, is positioned behind our sun. It's in the one location in our entire solar system where our telescopes cannot observe it. For 6 weeks from late October through early December, it operates in perfect concealment. If it wanted to change course, deploy subsystems, perform a maneuver that would reveal its true nature, this would be the moment. And we wouldn't know until it emerges. The timing is exquisite, too exquisite. Arriving on dates that resonate with human cultural memory, disappearing at the moment when observation would be most critical, coinciding with equipment failures and government disruptions that create information gaps wide enough to drive conspiracy theories through. Either we're witnessing an extraordinary convergence of coincidences or something is being orchestrated with patience measured in decades. Tonight, we explore what might be the most significant astronomical event in human history, or the most elaborate information leak ever designed to prepare us for something we're not ready to see. We'll examine the alleged Fibonacci transmission and why it matters. We'll investigate the cascade of anomalies that have serious scientists ranking this object at a 6 out of 10 on the artificial intelligence scale. We'll explore the timing coincidences that defy probability, the data gaps that suggest either bureaucratic dysfunction or deliberate concealment, and what this visitor might be doing right now in the one place in our solar system where we cannot watch. We'll trace connections that stretch back to 1977 to a radio signal that lasted 72 seconds and was never heard again. We'll examine claims that this object is billions of years old, possibly carrying organic chemistry from an epoch when the universe was young. We'll discuss the psychological preparation humanity may be undergoing, whether we realize it or not, for a reality that includes others. Whether 3I Atlas is a chunk of ancient ice or a probe from another civilization, what's unfolding right now demands your attention. Because in December, when it emerges from behind the sun, we'll finally know if we've been watching a comet or if something has been watching us. The universe doesn't speak often, but when it does, it might speak in mathematics, in patterns older than our species, in synchronicities that feel too perfect to be random. And the question we face tonight isn't just about one object passing through our solar system. It's about whether we're ready to hear what the cosmos might be trying to tell us. Let's begin. In June 2025, the Atlas telescope system in Chile, designed to scan the sky for near-Earth asteroids and comets, detected something unusual. Not unusual in the sense of immediate danger. This object was millions of kilometers away, but unusual in its origin. The trajectory calculations were unambiguous. This visitor wasn't from our solar system. It had come from somewhere else, crossing the vast darkness between stars to arrive in our cosmic neighborhood with timing that seemed almost choreographed. The Atlas system, asteroid terrestrial impact. Last alert system consists of 4 telescopes spread across the globe, 2 in Hawaii, 1 in Chile, and 1 in South Africa. They're designed as humanity's early warning system, scanning the sky every night, comparing images to detect anything moving against the background stars. Most of what they find is familiar known asteroids, catalogued comets, the occasional piece of space debris, but every so often they catch something new. When Atlas Chile first flagged the object that would become 3I Atlas, it appeared as a faint smudge moving against the star field. Not fast interstellar objects don't move quickly relative to our perspective, but steadily with a trajectory that didn't match anything in the database. The initial designation was temporary, just another object requiring follow-up. But within days, as more observations accumulated and orbital calculations refined, the truth became clear. This was an interloper, a visitor from beyond. The object received the designation 3I Atlas, marking it as the third confirmed interstellar object humanity has ever detected. The I stands for interstellar, the 3 for its place in the sequence, and Atlas for the telescope system that found it. Simple enough, but nothing about 3I Atlas would remain simple. To understand why this matters, we need to step back and remember how rare these visitors are. For all of human history, from the first stargazers in ancient Babylon to the sophisticated observatories of the 20th century, every comet, every asteroid, every piece of cosmic debris we observed belonged to our solar system. They were family members born from the same cloud of gas and dust that formed the sun and planets 4.6 billion years ago. They orbit our star. They follow predictable paths. We know them. Our solar system is vast, containing trillions of objects, from planet-sized worlds to microscopic dust grains. The Oort cloud, a theoretical sphere of icy bodies surrounding the solar system at distances up to 100,000 astronomical units, contains perhaps billions of comet nuclei. The Kuiper Belt, closer and beyond Neptune, harbors hundreds of thousands of icy worlds. The asteroid belt between Mars and Jupiter teems with rocky bodies. All of these belong to our system, all shaped by the same formative processes, all orbiting the same central star. We study them, we catalog them, we sometimes visit them with spacecraft. They tell us about our origins, about the conditions that led to Earth's formation, about the early violence of planetary accretion. They're artifacts of creation, frozen in time, carrying records of events billions of years gone. But they're all local, they're all ours. Until October 2017, we had never detected anything that came from elsewhere. Then everything changed. Astronomers detected Oumuamua, a name from Hawaiian meaning scout or messenger from afar, arriving first. It was peculiar from the start, elongated tumbling, moving on a trajectory that proved beyond doubt it came from another star system. It accelerated slightly as it left the inner solar system, a non-gravitational push that could have been outgassing like a comet or could have been something else entirely. Avi Loeb, chairman of Harvard's astronomy department, made international headlines by suggesting it might be artificial, a light sail perhaps, or a probe. The scientific community largely dismissed this. The acceleration could be explained by comet-like outgassing of hydrogen, which is invisible but creates thrust. Problem solved. Move along. But the door to considering artificial interstellar objects had been opened just a crack. The question was now askable, even if the answer remained almost certainly no. 2 years later, in August 2019, amateur astronomer Gennady Borisov spotted 2I Borisov from his personal observatory in Crimea. This one looked and behaved exactly like a normal comet, icy outgassing water and carbon monoxide, leaving a visible tail unremarkable in every way except for its extrasolar origin. It was almost a relief. See, the universe is full of comets. They wander between stars. Sometimes they pass through solar systems. Nothing mysterious here. Just cosmic wanderers, frozen relics ejected from their birth systems by gravitational interactions with giant planets, now drifting through the galaxy's vastness. The detection of 2I Borisov established that interstellar objects weren't rare flukes. They're out there passing through all the time. We just hadn't been looking carefully enough to spot them. The Vera Rubin Observatory, scheduled to begin operations in 2025, is expected to detect several interstellar visitors per year once it's fully operational. The era of interstellar object astronomy has begun. But 3i Atlas is different. The trajectory alone raises eyebrows among those who study orbital mechanics. Unlike the previous visitors, which passed through our solar system at high inclinations, meaning they came in at steep angles relative to the plane where planets orbit, 3i Atlas approaches within 5 degrees of the ecliptic. The ecliptic is that imaginary disk where Earth, Mars, Venus, and the other planets circle the Sun. It's the plane of our solar system's activity, the flattened disk of material left over from the solar nebula that gave birth to everything we see. Random objects from interstellar space should arrive from random directions. The galaxy is three-dimensional. There's no preferred plane. If interstellar comets are being ejected from other planetary systems at random angles, they should enter our system from random directions too. The probability of an object naturally aligning this closely with the ecliptic plane is less than 1%. Not impossible, low probability events happen all the time if you wait long enough, but unlikely enough to notice. Unlikely enough to make astronomers pause and check their calculations twice. And 3i Atlas doesn't just pass through. It executes close approaches to multiple major planets. It passes within reasonable proximity to Venus, close enough that only 5 kilometers per second of velocity change would put it on an intercept course.
Mars, the same, under 5 kilometers delta V to intercept. Jupiter, the gas giant that dominates the outer solar system, less than 5 kilometers through most of November. These are numbers that matter in spacecraft design. These are numbers that represent achievable maneuvers, with chemical propulsion, the kind of rockets we build today. The trajectory seems designed to observe these worlds up close, with minimal velocity changes required to intercept any of them. If you were planning a reconnaissance mission through an alien planetary system and wanted to maximize observation opportunities while minimizing fuel costs, this is what the trajectory would look like: efficient, optimized, intentional. More strangeness. It's on a retrograde orbit, meaning it's traveling opposite to the direction planets orbit the Sun. This isn't impossible for an interstellar object. It just means it approached from a direction opposite to the solar system's general motion around the galactic center. But combined with the low inclination, it creates a trajectory that's both statistically unusual and, if we're being honest, tactically advantageous if you wanted to study multiple planets without being easily detected. The retrograde motion increases relative velocity during flybys, allowing faster data collection before moving out of range. And the low inclination keeps you in the plane where interesting things like habitable planets tend to exist. The team at the Keck Observatory in Hawaii began detailed spectroscopic observations in August 2025. Spectroscopy is one of the most powerful tools in astronomy. You take light from an object and split it into its component wavelengths, creating a spectrum, a rainbow with dark or bright lines at specific wavelengths. Different chemicals absorb or emit light at specific wavelengths, creating unique fingerprints. By reading these fingerprints, we can determine what objects are made of from across vast distances. We can analyze the atmospheres of planets orbiting other stars. We can measure the composition of galaxies billions of light years away. And we can analyze the chemistry of a comet from another star system as it passes through ours. What the Keck team found in the spectrum of 3i Atlas was the first hint that this wasn't going to be a normal comet. The first suggestion that something about this object doesn't quite fit the categories we use to organize our understanding of the universe. But we're getting ahead of ourselves. First, we need to understand what happened on October 13th and why that date matters more than any other in this entire mystery. Why the timing, the synchronicity, the perfect alignment of calendar and cosmos feels less like coincidence and more like choreography, because October 13th, 2025 is exactly 108 years after one of the most witnessed, most documented, and most unexplained events in modern history.
An event where the sun itself seemed to dance in the sky while tens of thousands watched. An event that was predicted months in advance down to the specific date and location. An event that has never been satisfactorily explained by either natural phenomena or divine intervention, leaving it suspended in that uncomfortable space where neither science nor religion can fully claim it. The universe doesn't forget anniversaries. And neither, apparently, does whatever sent 3i Atlas.
Let's go back to October 13th, 1917. The place is the Cova da Iria, a rural area near the town of Fatima in Portugal. Between 60,000 and 100,000 people have gathered in a muddy field, many having traveled for days. They've come because 3 shepherd children, Lucia Santos and her cousins Francisco and Jacinta Marto, claimed the Virgin Mary had been appearing to them monthly since May. And Mary, according to the children, had promised a miracle on this specific date, October 13th, that would prove the apparitions were real. The crowd was a mixture of believers, skeptics, and journalists. Some came to pray, others came to mock. The Portuguese government at the time was actively hostile to the Catholic Church, and many officials attended hoping to expose the whole affair as fraud or delusion. It was raining. People were soaked, standing in mud, waiting. Around noon, the rain suddenly stopped. The clouds parted.
And then, according to multiple independent accounts from believers and skeptics alike, the sun appeared to change colors: silver, yellow, blue, then red, spinning like a wheel and appearing to plunge toward the earth before returning to its normal position. The entire event lasted about 10 minutes. People reported that their clothes, which had been soaked moments before, were suddenly dry. Some witnesses saw visions. Others reported seeing nothing unusual with the sun, but experienced the phenomenon differently, feelings of profound peace or terror. The accounts vary, but the core observation remains consistent. Something anomalous happened in the sky above Fatima on October 13, 1917, and it was witnessed by tens of thousands of people simultaneously. Skeptics have offered various explanations: mass hallucination induced by staring at the sun, atmospheric optical effects caused by dust or moisture in the air after the rain, psychological suggestion amplified by religious fervor and expectation. But none of these fully account for certain details: the dried clothing, the fact that people in different locations miles apart reported the same sequence of events, the absence of any reported retinal damage despite allegedly staring at the sun, and most significantly, the prediction made months in advance that something unusual would happen on that specific date. Whatever occurred at Fatima, divine miracle, atmospheric phenomenon, or something else entirely, it remains one of the most documented anomalous events in history. The Catholic Church eventually declared it worthy of belief, but the event transcends religious interpretation. Something happened. Thousands saw it. No consensus explanation has ever fully satisfied both the witness accounts and the physical evidence. Now jump forward exactly 108 years. October 13th, 2025. David Sereda, an independent researcher who has spent years developing what he calls a hyperdimensional solar system model based on sacred geometry and the golden ratio, publishes an analysis claiming that 3i Atlas emitted light pulses in a specific sequence on this date, 5-8-13. The Fibonacci sequence. Sereda claims these pulses correspond to specific celestial domains in his framework. 5 represents Earth. 8 represents what he calls the dominions, associated with a theoretical planet with a 591-day orbit. 13 represents the virtues, another hypothetical orbital zone in the outer system. Now, before we go further, we need to be clear about what this claim is and isn't. This is not confirmed by NASA or any major observatory. Sereda himself openly questions whether what he's presenting is a hoax, a genuine leak of classified data or information being released through unconventional channels to avoid direct attribution. He notes that 2 previous alleged leaks about 3i Atlas that initially appeared fake, later turned out to contain accurate information that was only confirmed by official sources weeks afterward. The claim is unverified. But the timing, the exact 108th anniversary of Fatima, is what makes people pause. Because 108 isn't just any number. It appears across multiple cultural and mathematical contexts with a frequency that suggests either deep significance or our tendency to find patterns where none exist. In Hindu and Buddhist traditions, 108 is sacred. Prayer malas have 108 beads. There are said to be 108 Upanishads, 108 sacred texts. The distance from Earth to the Sun is approximately 108 times the Sun's diameter. The distance from Earth to the Moon is approximately 108 times the Moon's diameter, though these ratios vary with orbital position. In human physiology, 108 degrees Fahrenheit is the temperature at which cells begin dying from heat. And 108, as researcher Richard Hoagland points out, creates harmonic relationships. 108 times 2 equals 216 times 2 equals 432, the frequency in hertz that some researchers associate with natural resonance as opposed to the modern concert pitch standard of 440 hertz. Are these connections meaningful, or are we engaging in numerology finding patterns because we want to find them? That's the question that haunts this entire investigation. But here's what makes it uncomfortable for pure skeptics. On October 13, 2025, NASA's Solar Dynamics Observatory, one of our primary tools for observing solar activity and anything passing near the sun, went offline. The official explanation: routine maintenance. The SDO monitors the sun continuously, streaming data in real time. It's one of the instruments that would be most likely to detect unusual activity from an object positioned near or behind the sun, and it went dark on October 13th. Coincidence? Almost certainly. Maintenance schedules are planned far in advance and don't coordinate with obscure anniversaries or alleged interstellar signals. But the timing is the kind of thing that makes even level-headed scientists squint. Because if you were going to do something unusual while positioned behind the sun, the moment when Earth's solar monitoring systems are offline would be the moment to do it. Then there's HiRISE, the high-resolution imaging science experiment aboard NASA's Mars Reconnaissance Orbiter. This camera is powerful enough to resolve objects down to 30 centimeters per pixel on Mars's surface. At 3i Atlas's distance during its October flyby, HiRISE could potentially resolve features as small as 30 kilometers across, enough to see structural details, surface anomalies, anything that might suggest this object isn't just a dirty snowball from another star system. HiRISE went offline on October 1, 2025. The official explanation is that one of the camera's electronics units has been failing since August 2023, and the complete shutdown occurred right before the optimal observation window. Plausible. But the timing again is suspicious. The best chance we had to image 3i Atlas at high resolution from Mars, and the camera fails. Add to this the broader context. On October 1st, the United States government entered a shutdown over budget disagreements. More than 15,000 NASA employees were furloughed. 2 days later, 3i Atlas made its closest approach to Mars. 29 million kilometers, the best opportunity for detailed imaging and spectroscopy. And yet, as of mid-October, no official high-resolution images have been released, no processed data from the Mars orbiters, no updates beyond preliminary statements essentially saying it's probably just a comet. The European Space Agency released a few images from their Mars Express and ExoMars Trace Gas Orbiter showing 3i Atlas as a faint white dot. That's it. Nothing with the resolution we were promised. Nothing that would help determine if this object is unusual beyond its trajectory. So when David Sarita publishes analysis claiming 3i Atlas sent Fibonacci pulses on the Fatima anniversary, the immediate response isn't just, is this true? It's, is this a leak? Is someone with access to classified data releasing information through channels that provide plausible deniability? This is the pattern we've seen in other high-strangeness cases. Information appears in fringe communities or through unverified sources. It's dismissed as conspiracy theory or fabrication. Then, quietly, elements of it are confirmed through official channels weeks or months later, but never with direct acknowledgement. The phenomenon gets plausible deniability. The insiders who leaked it avoid consequences, and the public is left trying to assemble a puzzle where half the pieces are labeled fiction and the other half are labeled classified. October 13th, 1917, the sun dances in the sky. October 13th, 2025, an object from another star allegedly speaks in the language of mathematics. 108 years apart. Both events predicted or analyzed in advance. Both involving celestial phenomena. Both creating more questions than answers. The Fatima connection might be coincidence. The universe is under no obligation to respect our calendars or our anniversaries. But if an intelligence wanted to get our attention to bypass scientific gatekeepers and speak directly to the part of human consciousness that recognizes pattern and meaning, using our own cultural touchstones would be devastatingly effective. A radio signal at the hydrogen line is elegant, but it only reaches scientists. A visual spectacle on a religiously significant anniversary reaches everyone. It speaks to something deeper than rational analysis. It speaks to the part of us that still looks up at stars and wonders if we're being watched. Whether that's what's happening here, whether there's any there at all, we won't know until December. But the timing is perfect, too perfect. And perfect timing is either the fingerprint of intelligence or the universe's favorite joke. Before we go deeper into what the alleged Fibonacci signal might mean, we need to understand what the Fibonacci sequence actually is and why it appears throughout nature with a frequency that borders on uncanny. Because this isn't just about three numbers, 5, 8, 13. This is about a mathematical pattern that seems to encode the universe's preferred way of organizing itself from the spiral of galaxies to the curl of a fern frond. The sequence is simple to generate, deceptively simple. You start with 0 and 1. Each subsequent number is the sum of the previous two. So 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on to infinity. Any child can generate this sequence with basic addition. You don't need calculus. You don't need higher mathematics. Just addition, the first operation we learn after counting. But hidden within this simplicity is something profound, something that has fascinated mathematicians, artists, and mystics for centuries. As the sequence progresses, something remarkable happens. The ratio between consecutive numbers approaches a specific value, approximately 1.618. This is phi, the golden ratio, often represented by the Greek letter F. It's an irrational number, meaning its decimal expansion goes on forever without repeating, 1.6180339887, continuing into infinity without pattern. But unlike other irrational numbers, pi, for instance, or the square root of 2, phi has unique mathematical properties that make it appear throughout geometry, algebra, and nature in ways that seem almost intentional. Take a rectangle where the ratio of the long side to the short side is exactly phi. If you remove a perfect square from this rectangle, the remaining rectangle also has sides in the ratio of phi. You can repeat this process infinitely, and each time the leftover rectangle maintains the same proportions. It's self-similar, fractal-like each generation, a perfect echo of the one before. If you draw a quarter circle arc connecting the corners of each successive square in this process, you create the Fibonacci spiral, a logarithmic spiral that expands outward while maintaining the same shape at every scale. This spiral doesn't change its fundamental character as it grows. It's the same spiral whether you're looking at the innermost curl or the outermost reach. This property, self-similarity across scales, is rare and beautiful in mathematics. Now step outside. Look at nature. The chambered nautilus, that elegant mollusk that's been building its shell the same way for hundreds of millions of years, grows in a perfect logarithmic spiral. As it grows, it adds new chambers to its shell, each one larger than the last.
but the overall spiral shape remains constant. The ratio between successive chamber sizes approximates phi. Look up.
The spiral arms of galaxies' vast structures containing hundreds of billions of stars stretching across hundreds of thousands of light-years follow logarithmic spirals. Our own Milky Way seen from above displays spiral arms that curve outward in patterns described by the same mathematics that describe a nautilus shell. The galaxy is vastly larger, infinitely more complex, yet it follows the same geometric rules. Walk through a garden. Examine a sunflower. The seeds in the flower's center are arranged in two sets of spirals, one curving clockwise, the other counterclockwise. Count them. You'll find the number of spirals in each direction are consecutive. Fibonacci numbers, typically 34 spirals in one direction and 55 in the other, or 55 and 89 or 89 and 144, depending on the flower's size. Always consecutive Fibonacci numbers. This isn't coincidence. This is optimization. The Fibonacci spiral represents the most efficient way to pack seeds in a circular space while ensuring each seed has maximum access to nutrients and light. Nature, through millions of years of evolutionary pressure, has discovered that Fibonacci numbers solve certain packing problems optimally. Plants that pack their seeds randomly reproduced less successfully than plants whose genetic coding led to Fibonacci arrangements. Over time, the optimal solution won. Pine cones show the same pattern. The scales spiral around the cone in two directions, and the numbers of spirals are Fibonacci numbers. Pineapples display the pattern in their hexagonal scales. Romanesco broccoli, that stunning fractal vegetable, grows in spirals of spirals, each following Fibonacci proportions. The arrangement of leaves on plant stems often follows Fibonacci angles, specifically the golden angle of approximately 137.5 degrees, which is derived from phi and ensures each leaf gets maximum sunlight exposure without shading the leaves below it. The human body exhibits golden ratio proportions, though not perfectly. Biology introduces variation. The ratio of your height to the distance from your feet to your navel approximates phi. The ratio of your total arm length to the length of your forearm. The spacing of facial features tends to cluster around golden ratio relationships. These aren't exact. Human bodies are too variable, too influenced by environment and genetics, but the statistical clustering is significant enough that artists throughout history have used these proportions to create aesthetically pleasing representations of the human form. Leonardo da Vinci studied these proportions extensively. His drawing, Vitruvian Man, explores ideal human proportions based on classical Roman architect Vitruvius's work, and many of these proportions approximate golden ratios.
Renaissance artists consciously used phi in their compositions because paintings structured around these proportions felt more balanced, more harmonious to the eye. Why? What is it about this specific ratio, 1.618, that our brains find satisfying? Some researchers suggest it's because our visual processing system evolved in an environment full of Fibonacci spirals and golden ratio proportions. We evolved surrounded by plants, by spiraling shells, by patterns following these mathematical rules. Our brains learned to recognize them as signals of a healthy, properly functioning natural environment. Deviation from these patterns might signal disease damage or artificiality, things worth paying attention to, potential threats. So our neural architecture rewards us with aesthetic pleasure when we encounter these familiar ratios, reinforcing attention to normal, healthy patterns. Others suggest it goes deeper, that consciousness itself might have mathematical structure, and phi could be somehow fundamental to how awareness organizes information. This ventures into territory that science can't easily test. We don't yet have a theory of consciousness sophisticated enough to make testable predictions about its mathematical foundations. But it's worth noting that some models of quantum consciousness, like Roger Penrose and Stuart Hameroff's orchestrated objective reduction theory,
propose mathematical relationships underlying subjective experience. Whether phi plays a role is speculative, but the question is at least askable. Art and architecture throughout history have used golden ratio proportions because they create compositions that feel right. The Parthenon in Athens, built in the 5th century BCE, incorporates phi in the relationships between height, width, and spacing of columns. The pyramids of Giza encode mathematical relationships, including approximations of phi in their dimensions. Medieval cathedrals designed by master builders who understood geometry deeply, even if they couldn't express it in modern mathematical notation, use these proportions. The facade of Notre Dame de Paris, the floor plan of Chartres Cathedral, look closely, and you find golden rectangles everywhere. Renaissance artists made it explicit. Luca Pacioli wrote De Divina Proporzione, the divine proportion, in 1509, with illustrations by Leonardo da Vinci exploring the mathematical and aesthetic properties of phi. The term divine proportion itself reveals how these thinkers viewed the golden ratio not just as mathematics, but as evidence of cosmic order, of underlying harmony in creation. Modern designers still use phi. The Dimensions of Credit Cards book covers photographs many default to proportions close to the golden ratio, because designs based on these proportions are more pleasing to look at. Apple's logo, if you overlay golden ratio circles, fits the pattern almost perfectly. Whether this was intentional or subconscious pattern matching by the designer is debatable, but the result is the same, a logo that feels balanced. Now bring this back to 3i Atlas and the alleged Fibonacci pulse. If the claim is real, if the object transmitted the sequence 5, 8, 13, it's communicating in a language that transcends human culture. These aren't arbitrary numbers. They're not references to Earth's history or Western mathematics. They're fundamental. Any intelligent species that studies mathematics, that observes nature, that looks at spiraling structures and growing patterns, would discover the Fibonacci sequence. It's not invented. It's not culturally dependent. It's discovered the same way we discover that 2 plus 2 equals 4, regardless of what symbols we use to represent those concepts. This is why Fibonacci numbers keep appearing in SETI discussions and hypothetical contact scenarios. If you wanted to send a message that any technologically advanced species would recognize as artificial rather than natural, you'd use mathematical constants. Prime numbers are a classic choice. 2, 3, 5, 7, 11, 13. These don't appear in nature with regularity. Transmitting them demonstrates you understand number theory, that you're capable of abstract mathematical thought. The Fibonacci sequence is similar but subtler. Yes, it appears in nature, but sending it as a deliberate signal light pulses with specific timing. Following this exact sequence demonstrates intent. It says, I know what Fibonacci is. I understand the mathematics underlying natural patterns. I'm choosing to use this sequence. I'm communicating, not just existing.
The difference between natural Fibonacci patterns and artificial Fibonacci signals is intention and context. A nautilus shell follows this pattern because physics and biology lead inevitably to this solution. It's not choosing to be a Fibonacci spiral. It's the result of growth algorithms encoded in its DNA interacting with physical constraints. But transmitting 5, 8, 13 as discrete pulses requires selection. It requires understanding that these numbers form a meaningful sequence and choosing to broadcast them. That choice is the signature of intelligence. But, and this is crucial, we don't have independent confirmation that 3i Atlas actually transmitted these numbers. What we have is one researcher's analysis released at a symbolically significant moment claiming something extraordinary. The raw data hasn't been shared. Other observatories haven't confirmed it. The claim exists in limbo, neither proven nor disproven. The question isn't whether Fibonacci numbers are important.
They clearly are deeply woven into the structure of reality in ways we're still discovering. The question is whether 3i Atlas actually transmitted them or whether we're seeing a pattern we desperately want to see. Our brains are exceptional pattern recognition engines. We evolved to find patterns because patterns meant understanding, and understanding meant survival. Recognizing that certain berries were poisonous while others were nutritious, that certain animal behaviors signaled aggression while others signaled fear. These pattern recognition abilities kept us alive, but the cost of this ability is that we sometimes see patterns where none exist. We see faces in clouds, hear words in random noise, find meaningful numerical relationships in coincidental data. This is called apophenia, the experience of seeing meaningful patterns in random or meaningless data. It's not a disorder. It's not a failure of cognition. It's a feature and adaptive trait that errs on the side of finding patterns, because missing a real pattern was more dangerous than seeing a false one. So we're left with a choice, uncomfortable in its ambiguity. Either dismiss the Fibonacci claim as unsubstantiated speculation, wishful thinking, projected onto ambiguous data by pattern-seeking minds hungry for meaning, or entertain the possibility that an interstellar object on the anniversary of an unexplained phenomenon witnessed by tens of thousands spoke in the mathematical language of creation. Both positions require a kind of faith that established institutions are telling us everything they know, that data delays are purely bureaucratic, that equipment failures are coincidental, or faith that the universe is stranger and more meaningful than materialist science allows that consciousness and intelligence permeate the cosmos, that we're not alone and never have been. The honest position, the uncomfortable position, is to hold both possibilities simultaneously, to say, I don't know, but I'm paying attention. To acknowledge that our brains might be creating meaning where none exists, while also acknowledging that dismissing every anomaly as pattern matching might cause us to miss genuine signals. We wait for December, when the object emerges from behind the sun and we can finally see what it's been doing in the dark. We wait for more data for independent confirmation or refutation for evidence that moves the needle one direction or the other. Because if 3i Atlas did speak in Fibonacci numbers, the next question becomes urgent and unavoidable. What is it trying to say? And more pressingly, what do we say back? Let's set aside the Fibonacci pulse claim for now and focus on what we can confirm through peer-reviewed observations. Because even without alleged signals, 3i Atlas is strange enough to warrant serious attention. Not one or two oddities that could be explained away, but a cascade of anomalies that collectively paint a picture of something that doesn't quite fit anywhere. The anti-solar tail. Normal comets have tails that point away from the sun. This is fundamental physics. Solar radiation carries momentum, and when photons from the sun hit dust and gas particles in the comet's coma, they push them outward, creating the classic streaming tail we associate with comets. Every comet in history has followed this pattern. The tail always points away from the sun, regardless of the comet's direction of travel. On August 24, 2025, the Keck Observatory in Hawaii captured images of 3i Atlas that showed something different. There's a tail, faint but measurable, extending toward the sun, not away from it. This anti-solar tail extends for hundreds of kilometers in the sunward direction. The researchers at the University of Hawaii who analyzed the data confirmed it. They proposed an explanation: larger, heavier dust particles being ejected from the sun-facing side of the nucleus with enough velocity that they briefly travel toward the sun before solar radiation pressure and gravity curve them back. It's possible, the physics work barely. But it requires assuming an outgassing mechanism more powerful than what we typically see in comets. It requires the comet to be actively jetting material at high velocity, specifically from the sunward side, which is unusual because that's the side experiencing the most heating, and should be outgassing in all directions, not concentrated in a beam. Could it be natural? Yes. Is it common? No. It's the first time we've observed this behavior clearly in an interstellar object. The nickel without iron problem. Spectroscopic analysis from the Keck Cosmic Web Imager revealed prominent nickel emission lines in 3I Atlas's spectrum. Nickel is present in many comets. It's a relatively common element forged in stellar nucleosynthesis. But nickel and iron form together in stars. They're neighbors on the periodic table, similar in atomic structure, and generally exist in predictable ratios when found in space objects. 3I Atlas shows strong nickel emissions, but iron none detected. The absence is as significant as the presence. Avi Loeb was quick to point this out in his analysis. On Earth, the only known process that produces pure nickel emissions without iron is the carbonyl pathway, a chemical process, where nickel reacts with carbon monoxide under specific conditions to form nickel tetracarbonyl, a toxic compound used in industrial nickel refining. This process was discovered by Ludwig Mond in the 1880s and revolutionized metallurgy. Finding this signature in a comet from another star system is, to put it mildly, unexpected. The research team suggests that a natural carbonyl reaction could be occurring near the nucleus. Carbon monoxide is present, we know that from James Webb Space Telescope observations. If conditions are right, perhaps nickel in the nucleus is reacting with that CO to form nickel carbonyl compounds that then dissociate in sunlight, releasing pure nickel gas into the coma. It's chemically plausible. But the specificity of conditions required the right temperature-pressure concentrations makes it a very narrow explanation. It's possible, but it's threading a needle. The spatial distribution adds to the mystery. The nickel emission extends about 600 kilometers from the nucleus. Cyanide extends to 840 kilometers. Both form distinct plumes with clear boundaries, not the diffuse gradual fade you'd expect from random outgassing. This structure suggests heterogeneity, different chemicals coming from different locations on the nucleus or being produced through different mechanisms. The water paradox. NASA's Neil Gehrels Swift Observatory measured water production rates in July and August 2025. They found 3I Atlas is losing water at roughly 40 kilograms per second. That's like a fire hose running continuously. It's a lot of water for an object still relatively far from the sun. Most comets don't start heavy water loss until they're much closer inside 1 astronomical unit. But here's the paradox. When NASA's Transiting Exoplanet Survey satellite observed 3I Atlas back in May and June, before its official discovery, researchers stacked over 9,000 images looking for signs of a coma. They found almost nothing. The brightness profile was nearly identical to inactive asteroids. No extended envelope of gas and dust. Yet by July, barely a month later, the object is blasting water into space at industrial rates. The explanation offered is that gas and dust ejected in May wouldn't have had time to form a visible extended coma in the TESS images due to the time delay between emission and detection. Possible, but it creates a picture of an object that was essentially dormant at 6.4 AU from the sun, then suddenly switched on as it crossed some threshold distance. Comets do activate at different distances based on composition, but the speed of this transition is unusual. The backwards composition. James Webb Space Telescope observations from early August revealed 3I Atlas's composition, roughly 87% carbon dioxide, 9% carbon monoxide, and only 4% water by volume of volatiles being released. That's backwards. Normal comets, including the previous interstellar comet 2I Borisov, are water-dominated. Water ice is the primary volatile. Carbon dioxide and carbon monoxide are secondary. 3I Atlas flips that ratio. It's a carbon comet that happens to have some water, not a water comet with some carbon. This has implications for its formation environment. High carbon dioxide content suggests 3I Atlas formed in a region of its home star system that was colder than where most objects in our solar system formed. Carbon dioxide ice requires lower temperatures to condense than water ice. If 3I Atlas is carbon-rich, it likely formed in the outer reaches of its natal system in conditions similar to our Kuiper belt, but possibly even colder.
That tells us something about the planetary system it came from. It had a cold outer region with abundant carbon compounds. But it also raises questions about how such an object gets ejected into interstellar space. You need a gravitational interaction, probably with a large planet, to kick something out of a stable orbit. The trajectory. That shouldn't be. We covered this earlier, but it bears repeating. 3I Atlas approaches within 5 degrees of the ecliptic plane. Random interstellar objects should arrive from random directions. The probability of aligning this closely with the planetary plane is less than 1%. The retrograde orbit adds to the strangeness. Moving opposite to planetary motion is rare for solar system objects and suggests either capture or external origin. But combined with close approaches to Venus, within 5 kilometers delta phi, to intercept Mars, same in Jupiter under 5 kilometers through November, the trajectory looks optimized. If you were designing a reconnaissance path through a planetary system, minimizing fuel costs while maximizing observation opportunities, this is what you'd choose. Size uncertainty. The size estimates for 3I Atlas's nucleus range from 440 meters to 5.6 kilometers in diameter. That's a factor of 10 uncertainty, which is huge.
We're estimating size from brightness, but brightness depends on both size and reflectivity. If the surface is very dark, the object could be larger. If unusually reflective, much smaller. Avi Loeb calculated that for 3I Atlas to resist the rocket-like forces from outgassing and maintain its observed trajectory, it must have a mass of at least 33 billion tons. That's the lower limit. If you assume normal density, that mass requires a diameter exceeding 5 kilometers. If it's porous, like many comets, it needs to be even larger. If it's compact and dense, it could be smaller. The uncertainty in size translates to uncertainty in density, which affects our understanding of composition. A large, porous, icy body is consistent with a natural comet. A small, dense object with the same mass starts looking unusual. Not necessarily artificial, but at least requiring explanation beyond standard comet models. The rotation period 3I Atlas rotates once every 16 hours plus or minus about 3 minutes. That converts to 969.6 minutes. Now this is where we venture into numerology territory, so tread carefully. 969 is the age of Methuselah, in the Bible the longest-lived human in the Hebrew scriptures. Coincidence, almost certainly. But when you divide that rotation period by Earth's exact sidereal year, you get 2.654, which is within a fraction of a percent of phi squared. The golden ratio squared equals 2.618. Close, but not exact. In engineering, a 1% tolerance is standard for calling something a match. In numerology, anything within 5% counts. Which standard applies here? That depends on whether you think the universe encodes meaning into rotation periods or whether we're finding patterns we want to find. The cumulative weight. Taken individually, each anomaly has a potential natural explanation. The anti-solar tail could be heavy particles with high ejection velocity. The nickel without iron could be a rare carbonyl reaction. The water paradox could be delayed visibility. The carbon composition could reflect formation conditions. The trajectory could be statistically unlikely but not impossible. The size uncertainty is just measurement limitations. The rotation period could be pure coincidence. But how many coincidences do we accept before considering alternatives? Avi Loeb has placed 3I Atlas at a 6 on his scale, from 0, definitely natural, to 10, definitely technological. A 6 means we should be taking this seriously, not dismissing it out of hand. It means the anomalies have stacked high enough that the artificial hypothesis, while still a long shot, deserves investigation rather than ridicule. The problem is that investigating requires data. And the data we need, high-resolution imagery, detailed spectroscopy, continuous observation, is either delayed missing or was never captured, because the right instruments were offline at the critical moments. Which brings us to the most frustrating aspect of this entire mystery right now as you're listening to this. 3-Eye Atlas is in the one place in our solar system where we cannot watch it. And it will stay there for 6 more weeks, during which it could perform a maneuver that changes everything, and we wouldn't know until it emerges. That's not speculation. That's orbital mechanics. And it's infuriating.
There's a window of opportunity that opens exactly once during 3-Eye Atlas's passage through our solar system. A window where, if you wanted to do something without being observed, the geometry of orbital mechanics hands you perfect cover. That window opened on October 29, 2025, when the object reached perihelion, its closest approach to the Sun, and it won't close until early December. For roughly 6 weeks, 3-Eye Atlas is positioned behind the Sun from Earth's perspective, invisible to our telescopes, hidden in the glare of the star that gives us life. And if Avi Loeb's calculations are correct, this is precisely where and when an intelligent object would execute what's called a reverse Oberth maneuver. Let's break down what that means, because the implications are genuinely unsettling. The Oberth effect is a principle of orbital mechanics where a spacecraft gets maximum benefit from a propulsion burn when it's moving fastest. Speed amplifies the effectiveness of thrust.
For an object entering a solar system at high velocity, the best place to decelerate and capture into a bound orbit is right at perihelion, the closest point to the Sun. You're already moving fastest there due to gravitational acceleration. Fire your engines while you're at maximum velocity, and the Sun's gravity, well combined with your thrust, allows you to shed velocity much more efficiently than if you burned fuel out in deep space. It's counterintuitive. You'd think slowing down far from the Sun would be easier, but orbital mechanics doesn't care about intuition. It cares about energy states, and the math is unambiguous. The Oberth effect at perihelion gives you maximum bang for your buck. Now imagine you're an interstellar probe arriving in a system you want to study. You don't want to announce your intentions. You time your approach so that perihelion occurs when you're on the opposite side of the Sun from the civilization you're observing. They can't see you. Their solar monitoring instruments are either offline or looking at the wrong wavelength. You execute your burn drop into a solar orbit, and by the time you emerge on the other side, you're no longer an interstellar interloper heading back out into the void. You're a resident, and they won't know until you decide to reveal yourself. 3-Eye Atlas reached perihelion at 144 astronomical units from the Sun, roughly 215 million kilometers, placing it just inside the orbit of Mars, but still well within what astronomers consider the inner solar system. The exact date, October 29th to 30th, falls within a range that David Sarita has connected to other significant events, including traditional calculations of Prophet Muhammad's birth date. Whether that's meaningful or coincidental is up for interpretation, but the fact remains this object is now in the optimal position to change its trajectory without us knowing. Avi Loeb has been explicit about this risk. In multiple blog posts and interviews throughout October, he stated that if 3-Eye Atlas executes a velocity change of 30 to 40 kilometers per second during the perihelion passage, it could reach Earth as early as late November or December. That's not speculation, that's orbital mechanics. An object with sufficient propulsion using the Sun's gravity well as a slingshot could arrive in Earth's vicinity within weeks of perihelion. We wouldn't see it coming until it emerged from the solar glare already on an intercept course. The natural response is, but it's just a comet. Comets don't have engines. And that's correct. Natural comets don't. But 3-Eye Atlas has displayed enough anomalies that the question of whether it's entirely natural is no longer absurd. The nickel emissions without iron, the anti-solar tail, the rotation period, the trajectory. At some point, the stack of coincidences gets tall enough that refusing to consider alternatives becomes its own form of bias. What makes the current blackout particularly frustrating is that we do have assets in position to observe. The European Space Agency's JUICE spacecraft, The Jupiter Icy Moons Explorer, currently en route to Jupiter, has a relatively clear line of sight to 3I Atlas during November. The spacecraft is equipped with cameras, spectrometers, and particle sensors capable of detecting activity that Earth-based instruments can't see from behind the Sun. Observations are scheduled between November 2nd and 25th. But here's the catch. JUICE is so far from Earth right now and traveling in such a position relative to the Sun that it's using its high-gain antenna as a heat shield. It can only transmit data through its medium-gain antenna at a much reduced rate. The full data set from JUICE's observations of 3I Atlas won't be downlinked and processed until February 2026, 4 months from now.
4 months during which, if the object did something unusual, if it deployed smaller probes, if it altered course, if it showed any sign of artificial structure or propulsion, we won't know. The data exists sitting in JUICE's memory banks, traveling through the outer solar system, but it's functionally inaccessible. It's like watching a play through a keyhole and knowing that someone inside the theater has a full recording, but they won't show it to you until the play is long over and the actors have left the building. Maddening. The timing of Earth-based observation gaps adds to the frustration. NASA's government shutdown meant reduced staffing and delayed data processing starting October 1st. The high-rise camera on the Mars Reconnaissance Orbiter, the one that could have given us 30-kilometer resolution of 3I Atlas's surface, has been offline since October 1st. The Solar Dynamics Observatory went down for maintenance on October 13th.
Each of these has a plausible official explanation. Government shutdowns happen. They disrupt operations. Cameras fail after years in space. Maintenance schedules are planned far in advance. None of it requires conspiracy. But from a public perception standpoint, the timing creates suspicion. When the most significant potential observation window coincides with equipment failures, government shutdowns, and data delays, trust erodes. It doesn't matter if the explanation is banal bureaucracy. The effect is the same. Absence of information gets filled with speculation. And right now, the speculation centers on a simple question: what is 3I Atlas doing behind the Sun? If it's just a comet, it's sublimating ice, releasing gas and dust, following a purely ballistic trajectory dictated by gravity and momentum. When it emerges in early December, it will be exactly where orbital calculations predict behaving exactly as comets behave. The anomalies will have explanations. The mystery will fade. But if it's something else, if it's under intelligent control, if it's executed a maneuver, if it's changed velocity or deployed subsystems, we won't know until December 19th when it makes its closest approach to Earth. At 1.8 astronomical units, about 269 million kilometers away, that's still far. Over 700 times the distance to the Moon, no collision risk, but close enough for serious observation once telescopes can see it again. Assuming, of course, that when we point our telescopes at the expected position, we find what we expect to find. Because if 3I Atlas has maneuvered, if it's altered course, the first sign will be that it's not where it should be. And that's when everything changes. The 6-week blackout is the perfect cover for action, or the perfect breeding ground for paranoia, depending on your perspective. The universe doesn't owe us transparency. Orbital mechanics creates blind spots. The Sun is a natural obstacle. None of this requires intent. But if you were designing a disclosure event, a moment where an interstellar object reveals itself to a global audience, primed by religious and cultural symbolism, you couldn't ask for better staging than emerging from behind the Sun on or around December 25th, Christmas Day, at Great Pyramid angle to Earth, which is exactly what's scheduled to happen. Coincidence? Probably. But the universe's sense of timing is impeccable.
Let's be clear about what we're discussing here. This is speculation-informed speculation based on orbital mechanics and anomaly analysis, but speculation nonetheless. The paper published by Avi Loeb and his colleagues Adam Hibbard and Adam Frank is titled, "Is the Interstellar Object Atlas Alien Technology?" The question mark is doing a lot of work in that title. The paper doesn't claim certainty. It presents a hypothesis for consideration, a thought experiment grounded in physics, but extending into possibilities that make most scientists uncomfortable. But the hypothesis is worth taking seriously, not because it's likely it probably isn't, but because the stakes are so high that even a small probability warrants investigation. If there's a 1% chance that 3i Atlas is artificial, the implications are so profound that dismissing it without thorough inquiry would be scientific malpractice. We've built careers on investigating phenomena with far smaller probabilities of significance.
Why would we refuse to investigate the one question that could fundamentally rewrite human history? Avi Loeb has staked considerable professional reputation on being willing to propose and defend hypotheses that push against the boundaries of acceptable scientific discourse. After Oumuamua, he suggested it might be artificial, a light sail perhaps, or debris from advanced technology. The backlash was immediate and fierce. He was called an attention seeker, a pseudo-scientist, someone who'd gone from respected researcher to fringe theorist. Op-eds were written. Subtle and not-so-subtle suggestions were made that perhaps it was time for him to retire, to stop embarrassing the field. But Loeb didn't retreat. He argued persuasively that science should follow evidence wherever it leads, not restrict inquiry to comfortable conclusions. If the data suggests something unusual, you propose unusual explanations and test them. You don't suppress hypotheses because they're weird. Weird is where discovery lives. Every paradigm shift in science began with someone proposing something that seemed absurd to their contemporaries. Heliocentrism was absurd. Continental drift was absurd. Quantum mechanics with its particles that exist in superposition and action at a distance was so absurd that Einstein spent decades trying to prove it wrong. Yet each of these absurd ideas turned out to be correct because scientists eventually prioritized evidence over comfort. So let's walk through the hypothesis, methodically assigning appropriate weight to different explanations and examining what the data suggests versus what our biases prefer. Hypothesis 1, natural comet, 60% probability. This is the baseline, the null hypothesis. 3i Atlas is an unusual comet, but unusual doesn't mean impossible. Comets vary widely in composition depending on where and when they formed. The conditions in the early solar system that produced our comets, temperature gradients, available elements, gravitational interactions, were specific to our history. Other star systems had different formation conditions. Different metallicity in their parent stars would create unusual elemental abundances. Different planetary configurations would eject different populations of comets into interstellar space. Our sample size of interstellar objects is tiny, only 3 confirmed over the entire history of astronomical observation. That's not enough to establish what's normal for objects from other star systems. It's like meeting 2 people from a foreign country and assuming you understand their entire culture. Statistically absurd. We don't yet know the full range of what's possible for objects from other stellar systems. The anti-solar tail could be explained by heavy particles ejected with unusually high velocity from localized jets on the sunward side of the nucleus. Comets don't outgas uniformly. They have active regions, areas where subsurface ice is closer to the surface or where particular volatile compounds are concentrated. A jet of material from one of these regions, aimed sunward, could create the appearance of a tail pointing toward the sun before solar radiation pushes it back. The nickel without iron signature could be a rare but natural carbonyl reaction. Carbon monoxide is abundant in 3i Atlas's coma. If temperatures and pressures near the nucleus are within a specific range, cold enough for chemical reactions to proceed slowly, but warm enough for some chemistry to occur, nickel in the nucleus could react with CO to form nickel tetracarbonyl. This compound is volatile and would sublimate, carrying nickel into the coma without iron. It's a narrow set of conditions, but narrow doesn't mean impossible. The carbon-heavy composition reflects formation in the cold outer regions of its natal system.
Carbon dioxide ice requires lower temperatures to condense than water ice. If 3I Atlas formed farther from its parent star than most of our solar system's comets, in a region where temperatures were too low for significant water ice formation, but perfect for CO2 ice, it would naturally be carbon-rich. Different star systems have different habitable zones, different snow lines where various compounds freeze. 3I Atlas's composition tells us something about its origin environment, but doesn't necessarily indicate anything artificial. The trajectory, while statistically improbable, isn't impossible. Low probability events happen all the time if you wait long enough. Roll a die 6,000 times, and you'll eventually see long runs of the same number. Improbable doesn't mean impossible. It just means we should notice it, verify it, and consider whether additional factors might explain why this particular improbable event occurred.
The rotation period matching biblical numerology and golden ratio calculations is coincidence and pattern seeking. With 969.6 minutes, we're rounding to 969 to match Methuselah's age. The actual measurement has error bars of plus or minus 3 minutes. Within that uncertainty, the rotation period could be anywhere from 966 to 972 minutes. We selected 969 because it has cultural resonance, but if the actual value is 967 or 971, we wouldn't be having this conversation about biblical connections. The division by Earth's orbital period yielding something close to phi squared is the same issue. We're working with approximate values and selecting the ratios that seem meaningful while ignoring the hundreds of other mathematical relationships we could calculate that don't have obvious significance. This is called the Texas sharpshooter fallacy, painting a target around the arrow after it's already been shot. If you calculate enough ratios, some will approximate important constants purely by chance. This natural explanation requires no new physics. It fits within established comet behavior stretched to accommodate unusual but not impossible characteristics. Scientific conservatism, the principle that we should prefer explanations that require fewer assumptions, favors this interpretation. Extraordinary claims require extraordinary evidence, and right now the evidence is suggestive but not extraordinary. Interesting, worthy of continued observation, but not sufficient to overturn our understanding of what interstellar objects are. If 3I Atlas continues on its predicted ballistic trajectory, after emerging from behind the sun, showing no deviations unexplainable by normal outgassing, and if detailed spectroscopy confirms standard cometry composition patterns beneath the surface-level oddities, this hypothesis is almost certainly correct. And that would be fine. Not every mystery needs to be aliens. Sometimes a comet is just a comet, and the universe is wonderful enough without needing to add intelligence to every unexplained phenomenon. Hypothesis 2. Exotic natural phenomenon. 25% probability. Perhaps 3I Atlas represents something we don't yet understand, a new category of object, or a process we haven't encountered before. This isn't invoking unknown physics, just acknowledging that our understanding of interstellar objects is in its infancy. We're extrapolating from 3 examples, which is scientifically dangerous. With such a small sample, our confidence intervals should be enormous, our certainty minimal. Think about the history of astronomy. Every time we've developed a new tool or technique, we've discovered phenomena we didn't predict. Radio astronomy revealed pulsars, which seemed so regular they were initially called LGM signals, little green men, because no known natural process could create such precise timing. Turned out to be neutron stars, natural but exotic. X-ray astronomy revealed black holes, accreting matter creating energetic phenomena we couldn't have imagined before we could see in that wavelength. Infrared astronomy revealed cool brown dwarfs, objects between planets and stars that don't fit cleanly into either category. Maybe there are formation mechanisms in other star systems that produce objects with characteristics unlike anything in our solar system. Stars with different metallicity, different abundances of elements heavier than hydrogen and helium, would have protoplanetary disks with different compositions.
A system forming around a metal-poor star from the galactic halo might produce comets with unusual chemistry. A system that experienced a supernova event nearby during its formation might have different isotope ratios, different volatile abundances. Passage through interstellar molecular clouds could coat the object with materials that alter its surface chemistry.
Space isn't empty. Between stars, there are diffuse clouds of gas and dust. An object traveling through one of these clouds for millions of years would accumulate a surface layer of whatever materials the cloud contained. This accretion could create surface composition different from the interior, potentially explaining some of the chemical anomalies. Interactions with cosmic rays over billions of years could alter surface chemistry in ways we haven't modeled. Cosmic rays, high-energy particles streaming through space. Break molecular bonds, create new compounds, alter isotopic ratios. Over timescales of billions of years, this bombardment could transform surface layers of ice and rock into compounds we don't see in younger objects from our own solar system. Maybe 3I Atlas is old. Really old. If it formed in the early universe when metallicity was different, when stellar populations were different, it might carry chemical signatures that reflect a universe we've never sampled. The universe is 13.8 billion years old. Our solar system is 4.6 billion years old. That means there were 9 billion years of stellar evolution, planetary formation, and comet creation before our system existed. 3I Atlas could be an artifact from that earlier epoch, carrying chemistry from a time when the universe was fundamentally different. This hypothesis says nature is weirder than our models account for, but it's still nature. It's not artificial, just unfamiliar. Further study of additional interstellar visitors will eventually reveal that 3I Atlas fits into a broader category we haven't defined yet. In 50 years, with hundreds of interstellar objects detected and characterized, we'll look back and say, oh, 3I Atlas was just a Type C carbon-rich interstellar comet, not uncommon, we were just surprised by the first one we saw. This explanation requires us to admit ignorance, which is intellectually honest, but psychologically uncomfortable.
We like to think our models are complete, that we understand the categories into which natural phenomena fit. Admitting we might have entirely missed a category of objects is humbling, but humility is appropriate. The universe is under no obligation to fit our preconceptions. Hypothesis 3, artificial probe. 15% probability. This is the bold speculation, the one that makes careers risky to advocate for and reputations easy to damage. But it's on the table, and the reasoning behind it is worth understanding in detail because it's more sophisticated than simple, it's weird, therefore aliens thinking. If you were an extraterrestrial intelligence designing a reconnaissance probe to study a planetary system without being detected until you chose to reveal yourself, what would you do? You'd make it look like a natural object. This isn't science fiction logic. It's basic strategic reasoning that any intelligence would follow.
Why? Because revealing your presence prematurely creates unpredictable responses. If the civilization you're observing is xenophobic or aggressive, announcing your presence might trigger defensive reactions. If they're scientifically primitive, they might misinterpret your technology as magic or divine intervention, creating religious movements that interfere with their natural development. If they're at a transitional stage, advanced enough to detect you but not advanced enough to understand you, you might cause social disruption that harms more than it helps. So you mimic nature. You give your probe a trajectory that appears ballistic, shaped by gravity and momentum indistinguishable from countless other objects drifting through space. You coat it with ice and rock so spectroscopic analysis reads as comet rather than manufactured object. You outgas volatiles at rates consistent with solar heating so it develops a coma and tail like any comet would. You do everything possible to pass as a natural object until the moment you decide revelation is appropriate. Only then, when the civilization reaches specific developmental thresholds, when they've proven they can detect interstellar objects and analyze their composition, when they've developed frameworks for thinking about extraterrestrial life, only then do you reveal yourself. And even then, you do it subtly. Mathematical signals rather than radio broadcasts. Gentle maneuvers rather than dramatic displays. You test their response, their readiness, before committing to full disclosure. In this framework, 3i Atlas isn't an alien spaceship in the Hollywood sense. There are no flashing lights, no smooth metallic hull, no obvious propulsion systems visible from Earth. It's a Trojan horse, a surveillance platform disguised so well that even being observed by advanced telescopes, it still reads as probably natural with some oddities. My Loeb's paper calculates the delta V, the change in velocity required for 3i Atlas to intercept various planets in our solar system from its current path. This is crucial because delta V is the fundamental currency of spaceflight. Every maneuver costs velocity. The more velocity you need to change, the more fuel or energy you require. For a probe traveling interstellar distances, minimizing delta V to reach targets of interest is critical to mission success. The calculations are striking. For Venus, the delta V required is less than 5 km before April 2025 and stays below 10 km through July. For Mars, it remains under 5 km through the end of July. For Jupiter, the intercept delta V is low, under 5 km all the way to November. These are numbers achievable with chemical propulsion, the kind of rockets we build today with no exotic physics required. Think about what that means. A probe with conventional propulsion could, from 3i Atlas's trajectory, reach Venus, Mars, or Jupiter with modest fuel expenditure. It could deploy smaller craft to these worlds for detailed study. It could position itself for long-term observation of any of them without requiring faster-than-light travel or antimatter drives, or any of the science fiction technologies we assume alien civilizations would possess. Earth is the outlier. The delta V to intercept Earth from 3i Atlas's trajectory is always above 5 km and often significantly higher depending on timing. But here's the strategic consideration that Loeb emphasizes. If the probe is following dark forest logic, you don't approach the inhabited planet directly. The dark forest hypothesis, while popularized by science fiction, has been discussed seriously in astrobiology and SETI circles for decades. The basic premise: the universe is a competition for finite resources. Any civilization that reveals its location risks being targeted by others, who see it as a potential threat or source of materials. The logical strategy for survival is silence. Don't broadcast, don't announce your presence. And if you send probes to other systems, make them stealthy, observant, and very careful about when and how they reveal themselves. In this framework, you don't approach Earth directly because that's where the potential threat lives. You approach the neighboring worlds. You release sub-probes for detailed study. You observe from a distance. You gather data on technological capability, social organization, aggressive tendencies. And if you determine the civilization poses a threat, if the dark forest logic demands preemptive action, you're positioned to act from multiple locations simultaneously, with the inhabitants having minimal warning. This sounds paranoid, perhaps even cruel, but from a pure survival standpoint, it's rational. If you're exploring a potentially dangerous environment, you don't walk in the front door. You watch from cover. You assess the situation. You only reveal yourself when you're confident the risk is acceptable. The trajectory of 3i Atlas allows observation of all major terrestrial planets with minimal fuel expenditure. The retrograde orbit, moving opposite to planetary motion, actually provides advantages. It increases relative velocity during flybys, allowing faster data collection as you pass each world. You're not lingering in anyone's observational range longer than necessary. You're moving through quickly, collecting data and moving on before detailed analysis can be performed. The low inclination to the ecliptic is similarly strategic. Stay in the plane where planets reside. That's where the interesting things are: habitable worlds, signs of life, evidence of technological civilization.
Traveling at high inclinations means spending most of your time in empty space far above or below the interesting regions. The timing of perihelion is the most suspicious element. 3i Atlas reaches its closest point to the Sun on October 29, 2025, when it's on the far side from Earth. If you wanted to perform a braking maneuver to capture into solar orbit rather than passing through and exiting, this is exactly where you do it. The Sun occludes observation from the planet you're most interested in studying. Your engine burn, if you're using conventional propulsion that produces a visible exhaust plume, is hidden behind 200 million kilometers of fusing hydrogen. Loeb calculated that a velocity change of 30 to 40 kilometers at perihelion would allow 3i Atlas not only to capture into solar orbit, but potentially to redirect toward Earth, arriving as early as late November or early December 2025.
That's not a slow approach we'd see coming for months. That's weeks between maneuver and arrival. The first indication would be the object appearing in an unexpected position when it emerges from behind the Sun in early December, already on a closing trajectory. Is this likely number? The probability is low, perhaps 10–15% at most, but it's not negligible. And the consequences of being wrong, of dismissing the possibility only to discover too late that we should have taken it seriously, are so severe that even a small probability justifies significant attention and resources. This is Pascal's wager applied to astrobiology. The expected value of investigating the artificial hypothesis, even at low probability, is enormous because the potential impact is so large. The expected value of dismissing it without investigation is also large, but negative. We might miss the most significant discovery in human history because it seemed unlikely and investigating it felt uncomfortable. The scale for evidence. Loeb has proposed a scale from 0 to 10, where 0 means definitely natural and 10 means definitely technological. This scale isn't arbitrary. It's a framework for organizing observations and assessing what additional evidence would change our confidence level. He ranks 3i Atlas at a 6, not probably artificial, but sufficiently anomalous to warrant serious investigation without ridicule.
To move higher on the scale, we'd need detection of artificial signals, radio or optical, that can't be explained as natural emissions. Observation of non-gravitational acceleration, that can't be explained by outgassing acceleration in directions inconsistent with solar heating or with magnitudes too large for volatile release. High-resolution imagery showing geometric structures, surface features, or symmetries, inconsistent with natural formation. Right angles, regular patterns, evidence of manufacturing. Spectroscopic signatures of manufactured materials. Pure metals in configurations that don't occur naturally, polymers, semiconductors, anything suggesting industrial processing, direct evidence of propulsion systems, exhaust plumes, thrust vectors, velocity changes executed on precise schedules. None of those have been detected yet.
The Mars flyby should have provided high-resolution imaging, but HiRISE was offline, and the images we got from other instruments show only a white dot. The spectroscopy reveals interesting chemical anomalies, but nothing definitively artificial. The window for close observation has closed, and now we wait. If 3i Atlas shows a delta V change after perihelion, if it emerges from behind the Sun on a trajectory that deviates significantly from ballistic prediction, it jumps to an 8 or 9 on the scale. That would be non-gravitational acceleration beyond what outgassing could explain, demanding serious consideration of propulsion. If it broadcasts a signal, radio, optical, anything coherent and clearly artificial, it's a 10. Confirmed artificial origin, proof that we're not alone, the most significant discovery in history. If it just continues on its path and fades into the distance, showing no deviations from ballistic trajectory, it drops to a 3 or 4. Unusual, worth studying for what it tells us about interstellar object populations, but probably natural. The anomalies become interesting footnotes rather than world-changing revelations. The scale is subjective, but it's a framework for thinking about evidence that moves the conversation beyond binary, is it aliens or not thinking. It allows for gradations, acknowledges uncertainty, and provides benchmarks for what additional observations would change assessments. It's how science should work, not claiming certainty where none exists, but quantifying confidence and updating beliefs as evidence accumulates. Whether 3i Atlas is artificial remains unknown. But the hypothesis is legitimate, the reasoning is sound, and the investigation is justified. That shift from obviously absurd to worth investigating is significant. Because once you admit the hypothesis is worth investigating, you also admit that we might not be alone.
And that admission, however cautious and probabilistically hedged, changes everything.
Now we venture into territory where mainstream science and alternative research diverge sharply. David Sarita's hyperdimensional solar system model is not accepted by mainstream astronomy. It won't appear in peer-reviewed journals. But it makes predictions, numerical predictions, and some of those predictions align with observable data in ways that are difficult to dismiss as pure chance. Whether that means the model describes reality or whether it's a case of fitting enough parameters to make any pattern appear is the central question, and it's a question without a clear answer. The foundation of Sarita's model is the number 591. Not approximately 591, but exactly 591.00. This number, he claims, represents the orbital period in Earth days of a hypothetical planet located between Mars and the asteroid belt, a planet he calls simply Planet 591. This planet doesn't exist in any official catalog. No telescope has ever imaged it. No gravitational perturbations suggest its presence. It's a theoretical construct, but here's where it gets interesting. Take 591 and divide it repeatedly by the golden ratio phi 1.618. What you get is a sequence of numbers that correspond sometimes with eerie accuracy to the orbital periods of known planets. Start with 591 divided by phi, you get 365.25. Earth's actual sidereal orbital period is 365.256 days, the time it takes for Earth to complete one orbit relative to the distant stars. The match is within 0.106 days. That's not approximate, that's nearly exact. Continue the sequence. Divide 365.25 by phi. Again, you get 225.7 days. Venus's orbital period is 224.7 days. Close within 0.5%. Next in the sequence, 139.5 days. Mercury's orbit is 87.97 days, which doesn't match cleanly, but Mercury is notorious for being difficult to fit into harmonic models due to its extreme proximity to the Sun and relativistic effects. Move in the other direction.
Multiply 591 by phi and you start approaching the orbital periods of the outer planets, though the matches become less precise as you move away from the central value. Mars shows a ratio relationship. Jupiter's orbital period of 4,333 days can be derived through multiple iterations of the phi ratio. The pattern becomes more complex but doesn't vanish entirely. Sarita's claim is that 591 represents the harmonic center of the solar system, the axis around which everything else rotates, both literally and figuratively. He connects this to the golden ratio because phi appears throughout natural systems not by accident, but because it represents optimal solutions to packing and growth problems, the spiral of galaxies, the arrangement of seeds in a sunflower. The proportions of the human body all exhibit phi relationships. If the solar system is organized according to phi, then finding a central frequency and scaling it by phi should reveal the structure.
And for the inner planets, at least it does. The question is whether this is discovery or invention, whether we're finding a real pattern or creating one through selective interpretation. The rotation period of 3i Atlas adds another layer. The object rotates once every 1616 hours, which equals 916.6 minutes. Now, 969 is the age of Methuselah, in the Bible the longest-lived human in Hebrew scripture, living 969 years before the flood. Is this significant? Probably not, except as a curiosity of pattern matching. But when you divide 969 by Earth's exact orbital period of 365.256 days, you get 2.654. Phi squared, the golden ratio, multiplied by itself equals 2.618. The rotation to orbital period ratio is 2.654, which differs from phi squared by about 1.4%. In engineering, a 1% tolerance is standard for calling something a match. In numerology, anything within 5% counts. So do we have a match or don't we? That depends on your standards. Sarita argues that 3I Atlas's rotation period confirms his model. The fact that an interstellar object arrives with a rotation period that fits into the phi-based harmonic structure suggests the structure is real, not invented. But critics point out that with enough mathematical manipulation, division, multiplication, rounding, selecting which ratios to examine, you can make almost any number fit almost any pattern. This is the numerology problem. Human brains are exceptional at finding patterns even in random data. We see faces in clouds, hear voices in white noise, and find mathematical relationships in coincidental numbers. The question is always, is the pattern inherent in the data, or are we imposing it? The Dante connection. Dante Alighieri completed Paradiso, the final section of the Divine Comedy, around 1321. In it, he describes the cosmos as a series of 9 celestial spheres, each associated with a different order of angels and specific virtues. From innermost to outermost, the moon angels, Mercury archangels, Venus, principalities, the Sun, powers, Mars, virtues, Jupiter, dominions, Saturn, thrones, the fixed stars, cherubim, and the primum mobile seraphim. Dante was working with the Ptolemaic model where Earth is at the center and everything revolves around it, but Sarita argues that Dante was encoding information possibly received through visionary experience, possibly through transmission from a non-human intelligence about the true structure of the solar system. When you adjust Dante's model to a heliocentric framework and apply the golden ratio as the organizing principle, the numeric structure maps onto Sarita's hyperdimensional solar system. The dominions associated with Jupiter in Dante's cosmology correspond to the 591-day orbital period in Sarita's model. The virtues associated with Mars correspond to the 13 value in the Fibonacci sequence. Earth, the inhabited world, corresponds to 5. If the alleged Fibonacci signal 5813 is real, it's referencing this framework directly. 5 is Earth. 8 is planet 591, the dominions. 13 is the virtues, the outer boundary of the inner system. The message, if it's a message, is saying, we understand your system, we know the hidden structure, and we're pointing to the key nodes. This is elegant as mythology. It's troubling as science, because it requires believing that Dante 7 centuries ago somehow intuited a structure that extraterrestrial intelligences also recognize, or that someone with deep knowledge of both human history and celestial mechanics is orchestrating an incredibly elaborate communication event. Problems with the model first. There's no observational evidence for Planet 591 if a planet existed between Mars and the asteroid belt. With a 591-day orbit, we would have detected it. It would perturb the orbits of asteroids. It would be visible in infrared surveys. Its gravitational influence would show up in the trajectories of spacecraft. None of that has been observed. So either the planet doesn't exist or it's somehow hidden, or the 591 refers not to a physical planet, but to a resonance, a gravitational harmonic, that affects orbits without requiring a massive body. Resonances do exist in the solar system. The Kirkwood gaps in the asteroid belt are caused by orbital resonances with Jupiter, but these are well understood and don't require invoking hidden planets. Second, the model requires accepting that phi is a universal organizing principle, not just a mathematical curiosity. Physics uses phi in specific contexts, the geometry of pentagons, the properties of quasi-crystals, but it doesn't treat it as a fundamental constant like the speed of light or Planck's constant. Elevating phi to that status requires philosophical assumptions about the nature of reality that aren't testable through experiment.
Third, the model has multiple layers of flexibility. You can multiply, divide, round, select which ratios to examine, and adjust reference frames. With that much flexibility, you can make almost any set of numbers align with almost any other set if you're creative enough. This is the same critique leveled at numerology, Bible codes, and other pattern-finding systems. If you search hard enough for patterns, you'll find them even in random data. But, and this is significant, the model made a prediction inadvertently. Sarita developed the hyperdimensional framework before 3i Atlas was discovered. He published his ideas about 591 and the phi sequence earlier in 2025, based on his interpretation of ancient texts and mathematical harmonics. When 3 Atlas appeared, its rotation period turned out to be 16.16 hours, or 969.6 minutes, and 969 happens to be Methuselah's age, and the ratio to Earth's orbital period happens to approximate phi squared.
Sarita didn't predict that 3i Atlas would have this specific rotation period, but his model, which treats these kinds of numerical relationships as significant, suddenly had a new data point that fit. That's either extraordinary coincidence or evidence that the model is capturing something real. The problem is we can't distinguish between those options without more data. One example isn't enough. You need multiple independent confirmations. If other interstellar objects show rotation periods or orbital characteristics that align with phi-based sequences, that would be compelling. If 3i Atlas is unique, it could just be chance. Sacred architecture Sarita also points to the Great Pyramid of Giza, which has a slope angle of 51,51 This angle, when extended as a line into the sky, points to specific regions of the ecliptic, where his proposed hyperdimensional planets would be visible if they existed.
On December 25, 2025, 3i Atlas will be positioned at this precise angle relative to Earth. The Great Pyramid encodes the relationship between a circle's circumference and its radius. Its perimeter to height ratio approximates 2p. Some researchers argue this is intentional, that the builders understood pi and encoded it structurally. Others argue it's a natural consequence of the pyramid's slope angle and the use of convenient units of measurement. The same debate applies to the 3i Atlas alignment. Is it meaningful that the object will be at Great Pyramid angle on Christmas Day, or is it coincidence that we're interpreting as synchronicity because we want to find meaning? If you're willing to entertain the idea that ancient civilizations had contact with or knowledge from non-human intelligences, then encoding astronomical data in monumental architecture makes sense. It's a way to preserve information across millennia. Stone lasts. Oral traditions fade. Writing systems change. But a pyramid aligned to cardinal directions, built with geometric precision, carries its message forward through time to anyone capable of reading it. The honest assessment. Sarita's model is not mainstream science. It's speculative, built on correlations that may or may not be causal, and it requires accepting metaphysical assumptions about mathematical structure that can't be tested empirically. But it's also not pure fabrication. There are numerical relationships that are hard to dismiss, and the rotation period of 3i Atlas fitting into the framework was not something Sarita could have engineered after the fact. The probability that the model describes reality is low, maybe 5 to 10%, but it's not zero, and in the absence of better explanations for the anomalies and synchronicities stacking up around 3i Atlas models like Sarita's fill a vacuum, they provide a framework for understanding events that otherwise seem random or meaningless. Whether that framework is discovery or invention, we'll know more in December. If 3i Atlas maneuvers, if it shows structure,
if it confirms any of the predictions made by those treating it as potentially artificial. Then models like Sarita's, which tried to find meaning in the anomalies, will suddenly look more credible. And if it doesn't, if 3I Atlas fades into the distance as just another interstellar chunk of ice, then the hyperdimensional solar system model joins the long list of interesting ideas that didn't pan out. But the beauty of science, real science, is that we get to find out. The object is still there. The observations will continue, and the data will either support or refute the hypothesis. That's how it should work, even if the hypothesis makes people uncomfortable. There's a hypothesis in astrobiology that doesn't get enough attention in popular discussions, probably because it's simultaneously elegant and unsettling. It's called panspermia, the idea that life doesn't originate independently on every planet, but spreads through space on comets, asteroids, and interstellar objects. If this is true, then 3I Atlas isn't just a visitor. It's potentially a delivery vehicle, and what it's carrying might be more significant than any signal it could transmit. Let's start with the age estimates. Multiple studies attempting to trace 3I Atlas's trajectory backward through the galaxy suggest it's been traveling for a very long time. The conservative estimate is 3 billion years. The upper estimate pushes to 14 billion years, which would make it older than our solar system, possibly dating back to the early universe when first-generation stars were seeding the galaxy with heavy elements. If 3I Atlas formed 14 billion years ago, it witnessed the Milky Way's adolescence. It drifted through clouds of gas and dust that would eventually collapse into stars and planets. It was ancient when Earth was forming. What does that age mean for biology? If the object is that old and has been preserving frozen material in its interior, it could contain organic compounds from an era of galactic chemistry. We can't sample any other way. Early stars had different metallicity, different abundances of elements, the building blocks of life. Amino acids, nucleotides, lipid membranes might have formed under conditions that no longer exist. 3I Atlas could be a time capsule carrying primordial organic chemistry that predates anything on Earth. The carbon dioxide dominance in its composition supports this. Carbon dioxide ice forms at lower temperatures than water ice. If this object originated in the cold outer regions of its natal star system, or even in interstellar space itself, it would preferentially accumulate carbon compounds. And carbon is the backbone of organic chemistry, the element that allows complex molecules to form the long chains and rings necessary for life. The fact that 3I Atlas is releasing carbon dioxide, carbon monoxide, and cyanide, all carbon-bearing molecules, suggests it's rich in the raw materials life uses. Now, cyanide gets a bad reputation because it's toxic to humans, interfering with cellular respiration. But in prebiotic chemistry, hydrogen cyanide is essential. It's a precursor to amino acids through the Strecker synthesis. It polymerizes into adenine, one of the nucleotide bases in DNA and RNA. The Miller-Urey experiment, which simulated early Earth's atmosphere and produced amino acids from simple chemicals and electricity, relied on cyanide chemistry. If 3I Atlas is releasing cyanide, it's releasing one of the key ingredients for life's origin. Not life itself, not yet, but the chemical precursors that make life possible. The objection is obvious. Space is harsh. Radiation vacuum temperature extremes. Organic molecules would degrade over millions of years, let alone billions. That's true for molecules on the surface exposed to cosmic rays and ultraviolet light. But the interior of a comet is protected. Meters of ice and rock shield the core from radiation. Temperature inside stays stable, well below freezing, preserving chemical structures indefinitely. We found amino acids in meteorites. The Murchison meteorite, which fell in Australia in 1969, famously contained over 70 different amino acids, some of which don't exist in terrestrial biology. Those molecules survived the meteorite's formation, its journey through space, and its fiery entry into Earth's atmosphere. If amino acids can survive, that they can survive inside a comet for eons. The OSIRIS-REx mission to asteroid Bennu confirmed that asteroids carry the building blocks of life. When the sample was returned to Earth and analyzed, it contained most of the amino acids necessary for biology plus organic compounds we hadn't expected. Bennu is a rubble pile asteroid that's been orbiting the Sun for billions of years, getting baked and irradiated. Yet the organics persisted. 3I Atlas, coming from interstellar space and spending most of its time in the deep freeze far from any star, would preserve organics even better. The interior has never been heated above a few tens of degrees Kelvin. Any organic molecules that formed when the object coalesced billions of years ago would still be there, frozen in stasis, waiting. The panspermia mechanism. Comets impact planets. When they do, some material survives the impact and mixes with the local environment. If that material contains preformed organic molecules, or more speculatively hardy microorganisms, it seeds the planet. Earth might have been seeded this way. Mars might have been. Venus, before it became a hellscape, might have been. The moons of Jupiter and Saturn, which have subsurface oceans, could still be receiving regular deliveries of organic material from impacts. 3I Atlas isn't going to hit Earth. Its trajectory keeps it far away. Closest approach 1.8 AU, over 700 times the distance to the Moon. But if it were to fragment, if pieces broke off due to thermal stress or tidal forces, those fragments could become their own objects with slightly altered trajectories. Some might eventually intersect Earth's orbit, not now, but in the future. Or they could impact other bodies in the solar system. If even one fragment lands in a hospitable environment, and if it carries viable biological material, you've just introduced extraterrestrial life. The definition of viable is key. Most panspermia scenarios don't require active reproducing organisms. They require chemical precursors, organic molecules that can kickstart abiogenesis, the transition from chemistry to biology. But there's a more radical version called lithopanspermia, which proposes that actual microbes, dormant but alive, travel through space inside rocks and ice. This requires organisms capable of surviving extreme conditions. And we know such organisms exist on Earth. Tardigrades, microscopic animals sometimes called water bears, can survive the vacuum of space. They enter a state called cryptobiosis, where metabolic processes essentially stop. They can remain in this state for years, even decades, and revive when conditions improve. Bacterial spores can remain viable for millions of years in dormancy. Experiments have shown that certain extremophiles can survive simulated interstellar conditions. If Earth life can do this, it's plausible that life elsewhere developed the same capability. Evolution tends to find similar solutions to similar problems. If surviving interplanetary or interstellar transport is advantageous, and it would be allowing colonization of new environments, then life would evolve mechanisms to survive it. Avi Loeb has proposed that future missions should attempt to intercept interstellar objects and sample them directly. Not flybys, but landing missions that drill into the surface and extract material for analysis. The goal would be to search for organic compounds and ambitiously for any signs of biological activity or structures that suggest life. If an interstellar object contained extraterrestrial microbes, even dead ones, it would revolutionize biology. We'd have a second example of life proof that it's not unique to Earth. And if the biochemistry was similar to ours, same amino acids, same nucleotides, same basic metabolic pathways, it would support panspermia. The implication would be that life on Earth and life elsewhere in the galaxy share a common origin, that we're cousins separated by billions of years and light years of distance. If the biochemistry were radically different amino acids, different genetic code, different solutions to the problems of metabolism and replication, it would suggest independent origins, which raises its own profound questions. How common is life? If it can start independently on multiple worlds,
The universe might be teeming with it. We'd no longer be wondering if we're alone. We'd be wondering why we haven't met anyone yet. The darker side. The darker side of panspermia is the possibility of harmful biology. If life can spread through space, so can pathogens. Imagine an interstellar object that fragmented a piece landed on Earth, and it carried microbes that are biochemically compatible enough with terrestrial life to interact, but foreign enough to be dangerous. Extraterrestrial plague.
This sounds like science fiction, and it probably is. The chances of alien biochemistry being compatible enough with Earth biology to cause infection, but different enough to evade immune systems, is vanishingly small. Most biologists think the biochemical differences between Earth life and any hypothetical alien life would be so great that there'd be no interaction. Earth microbes wouldn't be able to metabolize alien organic molecules, and vice versa. They'd be chemically inert to each other, like trying to run gasoline in a diesel engine. But we don't know that for certain. We've never analyzed extraterrestrial life. We're speculating based on a sample size of 1. If 3I Atlas is carrying anything biological, it's more likely to be chemical fossils than living organisms, organic molecules that once were part of life but are now inert. Those would still be incredibly valuable scientifically. They'd tell us about the chemistry of life in another star system, what elements were available, what pathways were used, whether the same solutions to the problems of metabolism and replication were found. Even negative results, finding that 3I Atlas has no organic chemistry at all, would be informative. It would tell us that the formation conditions were hostile to complex carbon molecules, which narrows the range of environments where life can start. The role of interstellar distribution. The role of interstellar objects in distributing life across the galaxy is an open question. If panspermia is real, then life might not need to originate de novo on every planet. It could start once somewhere and then spread as comets, and asteroids get ejected from that system and eventually land in others. Over billions of years, a single genesis event could populate an entire galaxy. That would make life common, but also related. Every instance of life in the Milky Way could share a common ancestor, not through evolution on a single planet, but through propagation across space. This has implications for the search for extraterrestrial intelligence. If life is seeded by panspermia, then the emergence of intelligence might follow similar timelines across many worlds. You could have waves of intelligence, cohorts of species that developed within the same few 100 million-year window because they all started from seeds distributed in the same epoch. That could explain why we haven't detected signals. Maybe we're in an early wave, and the galaxy is mostly empty of advanced civilizations because life is still getting started. Or maybe we're in a late wave and everyone else already rose and fell, leaving only ruins and dormant probes like 3I Atlas. Remote viewing claims mentioned in social media posts around 3I Atlas speculate that it's carrying microbial life and plans to drop it on Earth. This is almost certainly fantasy, but it taps into a primal fear, the idea that something from the sky could rain down and change life on Earth. Meteors were seen as omens. Comets were feared as harbingers of plague and war. Modern science mostly dismissed those fears as superstition, but panspermia suggests they might have been onto something not in a mystical sense, but in a literal one. Objects from space can carry biological material. It's just that most of the time that material is either destroyed on entry or so foreign that it doesn't interact with the existing biosphere. The ultimate test for 3I Atlas's biological potential would be spectroscopy, looking for specific biosignatures. Molecules like methane and oxygen together in the same spectrum would be unusual since they react and destroy each other unless continuously replenished by life. Chlorophyll or other pigments that absorb specific wavelengths of light for photosynthesis would be a smoking gun. We haven't detected anything like that, and we probably won't, but searching is how science advances. You look for the unexpected, and occasionally you find it. If 3i Atlas were to show even a hint of biological activity, the response would be immediate and intense. Every telescope would turn toward it. Funding for interception missions would materialize overnight. The paradigm would shift. Until then, the question remains hypothetical. Could 3i Atlas seed life in principle? Yes. It has the chemistry, it has the age, it has the protective ice shell. Whether it actually carries viable biological material is unknown and will likely remain unknown unless we sample it. But the fact that we can even ask the question seriously, that panspermia is a legitimate hypothesis discussed in peer-reviewed journals, shows how far our understanding has come. The universe is not sterile. It's full of organic chemistry, complex molecules, and the potential for biology to spread far beyond its origin. 3i Atlas is part of that story. Whether it's carrying life or not, it's a messenger from another part of the galaxy. And the message is that the building blocks are everywhere waiting for the right conditions to assemble into something that replicates, evolves, and eventually asks questions about where it came from. Let's step back to August 15th, 1977. The place is Ohio State University, where the Big Ear Radio Telescope, a massive fixed structure designed to scan the sky for radio signals, is operating as part of an early SETI program. The telescope doesn't move. Instead, the Earth's rotation sweeps its beam across the sky, allowing it to observe different portions of the celestial sphere as the day progresses. On this particular day, the telescope detected something unusual, a strong narrowband radio signal at 1420 MHz, the hydrogen line frequency, one of the most significant wavelengths in the universe, because it's where neutral hydrogen emits radiation. This frequency is often called the cosmic water hole, a place where any civilization looking for signals would naturally tune in. The signal lasted exactly 72 seconds, the maximum duration the telescope's beam would stay focused on any given point in the sky as Earth rotated. Its intensity profile was exactly what you'd expect from an astronomical source, rising to a peak as the telescope swept across it, then declining as the beam moved on. It had all the characteristics of something real, something distant, something not from Earth. Dr. Jerry Amon, a volunteer researcher reviewing the computer printout days later, was so startled that he wrote, "Wow," in the margin next to the data. The exclamation gave the signal its name. The wow signal appeared to originate from the direction of Sagittarius near the star group Chi Sagittarii. But when astronomers turned telescopes back to that region searching for a repeat transmission, they found nothing. Multiple follow-up observations over the following years detected no similar signal. The wow signal was a one-time event, never replicated, never explained. Over the decades, various hypotheses have been proposed. Maybe it was a comet that happened to be in the telescope's beam, outgassing hydrogen at exactly the right frequency. Maybe it was terrestrial interference, a reflection of Earth-based transmissions bouncing off space debris or aircraft. Maybe it was a natural astrophysical phenomenon we don't yet understand, some quirk of interstellar plasma or stellar activity. None of these explanations are fully satisfying. The comet hypothesis requires the comet to be outgassing at exactly 1420 MHz, which is possible but requires specific conditions. The interference explanation struggles with the fact that the signal had the expected rise and fall pattern of an astronomical source, not the irregular profile of reflection or noise. And the natural phenomenon explanation is just saying, "We don't know," with more words. What if the wow signal wasn't a beacon? What if it was an announcement, the trajectory connection? Avi Loeb noted something interesting when analyzing 3i Atlas's trajectory. If you trace the object's path backward through space, accounting for galactic motion and gravitational interactions, it passes through a region of sky very close to where the wow signal originated. The alignment isn't perfect. There's uncertainty in both the signal's exact origin and the object's trajectory over interstellar distances, but it's within the margin of error. The chance of this being random is approximately 6%, not impossible, but noteworthy. low enough to make you pause. If 3i Atlas transmitted the WOW signal decades ago as it approached our solar system, the timeline works. The signal was detected in 1977. 3i Atlas is here now in 2025. That's 48 years of travel time. Depending on its velocity and trajectory over the intervening decades, it could have been in the right position at the right time. But this requires assuming the object has been under intelligent control for at least 48 years, maintaining a course toward our system while announcing its approach with a radio burst. It's a huge assumption. It requires accepting that interstellar probes exist, that one is visiting our solar system, and that it deliberately transmitted a signal nearly half a century before its arrival. Why would it do that? Several possibilities present themselves. First, perhaps the signal was a deliberate notification, a cosmic courtesy call. We're coming. We've been watching. Don't be alarmed when we arrive. This assumes benevolent intent and an understanding of how long it would take for the receiving civilization to detect, analyze, and prepare for contact. Second, perhaps, it was a navigational beacon transmitted not for us, but for other probes, or for the civilization that sent it, marking position and trajectory. We simply intercepted it. In this case, discovering the signal would be accidental, eavesdropping on a conversation we weren't meant to hear. Third, perhaps it was a test, a probe of our detection capabilities and response protocols. How long would it take us to notice? Would we recognize it as potentially artificial? Would we attempt follow-up observations? The fact that we did detect it, that we did recognize it as anomalous, and that we did attempt follow-up suggests our technological development reached a threshold the sender wanted to measure. Fourth, perhaps there's no connection at all, and the alignment is coincidence. 6% probability isn't negligible. If you examine enough potential connections, some will appear significant purely by chance. Why the signal was never repeated? One of the most puzzling aspects of the WOW signal is that it was never detected again. Dozens of follow-up observations using more sensitive equipment found nothing. If it was a beacon, you'd expect it to repeat. Beacons don't broadcast once and stop. They transmit continuously or periodically specifically to be found. But if the signal wasn't a beacon, if it was a one-time announcement, then the lack of repetition makes sense. The message was, "We're coming." Once sent, there's no need to repeat it. The transmission served its purpose. By the time we developed the capability to search for a repeat signal, the sender was already en route, no longer in the position where the original transmission occurred. This hypothesis reframes the WOW signal not as a failed SETI detection, but as successful METI messaging to extraterrestrial intelligence in reverse. They contacted us, we received it, we didn't understand what it meant, and now 48 years later the sender arrives. The emotional resonance of this possibility is profound. It means we've been on notice for half a century. It means the contact process began long before most people alive today were born.
It means 3i Atlas isn't a random visitor, but the fulfillment of a promise made when humanity was just beginning to listen to the stars. But it also raises uncomfortable questions. Why announce arrival 48 years in advance? What preparations were they expecting us to make? And if this is contact, why the long delay? Why not transmit continuously, ensuring the message is received? Perhaps the delay is strategic. 48 years is enough time for a civilization to develop technologically, to mature socially, to prepare psychologically. The WOW signal in 1977 came at a moment when SETI was in its infancy, when the search for extraterrestrial intelligence was just becoming scientifically respectable. By 2025, we have better telescopes, better understanding of exoplanets, better frameworks for thinking about contact. We're more ready now than we were then. Or perhaps the delay is simply the time required to cross interstellar space.
If 3i Atlas was launched from a system several dozen light-years away, traveling at a fraction of light speed, 48 years is a plausible travel time from the point where it transmitted to the point where it arrives. Alternative explanations revisited. The comet explanation for the WOW signal proposes that a comet was in the telescope's beam, outgassing hydrogen that created emissions at 1420 MHz. This is possible. Hydrogen is the most abundant element in the universe, and comets do contain it. But the frequency needs to be exact, and the comet needs to be in precisely the right location, and the outgassing needs to be strong enough to register at interstellar distances, because if the comet was local within our solar system, its motion relative to Earth would have caused a Doppler shift, altering the frequency. The signal showed no Doppler shift, suggesting the source was either stationary relative to Earth, which nothing in space truly is, or very far away, where relative velocities become negligible. A comet in the outer solar system or in interstellar space might fit, but then you're invoking an interstellar comet outgassing hydrogen, which brings us back to 3I Atlas. The terrestrial interference explanation requires the signal to be a reflection or emission from Earth-based technology. Military radar satellite transmissions, something terrestrial, bouncing off a reflective surface in space. But the signal's frequency was tightly controlled. Its intensity profile matched astronomical expectations, and its duration aligned perfectly with the telescope's observational window. Terrestrial interference typically looks irregular, spiky, inconsistent. The WOW signal looked clean, like a deliberate transmission.
The unknown natural phenomenon explanation is science's way of saying, we don't know, but we assume nature can do weird things. It's not an explanation so much as a placeholder, an admission that the universe contains processes we haven't cataloged. It's intellectually honest, but it doesn't satisfy the curiosity that drives scientific inquiry. The pattern of one-time events. The WOW signal is part of a pattern. Events that happen once can't be reproduced and resist explanation. The Fatima phenomenon, the 1977 signal, and now potentially the Fibonacci pulses from 3I Atlas. Each is a singular occurrence. Each is witnessed or recorded, but never repeated under controlled conditions. Each generates intense speculation and remains unresolved. This could mean they're noise flukes, coincidences elevated to significance by pattern-seeking minds. Or it could mean they're intentional, designed to be noticed, but not confirmed to plant seeds of awareness without triggering definitive responses. If you wanted to prepare a civilization for contact, single anomalous events spaced decades apart might be the optimal strategy. Each event generates discussion, expands the Overton window of acceptable discourse, and normalizes the idea that we might not be alone. By the time actual contact occurs, it's anticlimactic. Everyone already half believed it. The shock is diminished. Social disruption is minimized. This is speculative psychology, trying to infer strategy from events that might not be connected at all. But the timing, the alignment, the cascading nature of the anomalies around 3I Atlas, all of it suggests either the universe has a sense of narrative timing or something is orchestrating events with long-term patience. We'll know more when 3I Atlas emerges from behind the sun. If it has maneuvered, if it shows structural features, if it transmits again, the WOW signal connection moves from interesting coincidence to potential confirmation of a decades-long contact process. And if it doesn't, if 3I Atlas continues on its ballistic path and fades into interstellar space, the WOW signal remains what it's always been, one of the most tantalizing unsolved mysteries in the history of radio astronomy. A moment when the universe seemed to speak, and we weren't sure if we heard correctly. Let's talk about us. Not the object, not the anomalies, not the mathematics us. Because how we're responding to 3I Atlas reveals as much about human psychology as any data from Keck Observatory or Mars orbiters. The patterns of belief, the fractures in consensus reality, the way information moves and mutates through social networks. All of it is diagnostic. We're watching ourselves try to process something that doesn't fit cleanly into existing categories, and the response is fascinating and troubling in equal measure. Start with the disclosure paradox. If you release information too early before you fully understand it, you risk causing unnecessary panic. If you withhold information while you assess the situation, you risk being accused of cover-up when the truth eventually emerges. There's no clean solution. The optimal strategy, transparent communication about what is known, what is unknown, and what is being done to find out, requires admitting uncertainty.
And institutions, especially governmental ones, are terrible at admitting uncertainty because it's perceived as weakness. So instead, we get what we're seeing now, vague reassurances that everything is consistent with cometry behavior, data delays attributed to bureaucratic slowness, and a conspicuous absence of the high-resolution imagery and detailed spectroscopy that should have been released weeks ago. Maybe it's genuinely just bureaucracy. Maybe it's deliberate information management. From the public's perspective, the effect is identical. The human brain is wired to detect agency. This is an evolutionary adaptation that kept our ancestors alive. When they heard rustling in the bushes, assuming it was a predator, and being wrong running from wind was less costly than assuming it was wind, and being wrong ignoring a tiger. We over-attribute intentionality. We see patterns and infer design even in random events. This is called hyperactive agency detection, and it's why conspiracy theories are so persistent. When something significant happens, an interstellar object displaying anomalies, arriving on symbolically important dates, coinciding with equipment failures, and government shutdowns and official explanations feel inadequate. The brain fills the gap with narratives that involve deliberate action. The shutdown wasn't random bad luck. It was timed to prevent data release. The camera failure wasn't technical malfunction. It was sabotage or suppression. Whether these narratives are true is almost secondary to the fact that they're plausible, and plausibility is enough for the brain to latch onto. Once you've constructed an explanatory framework that makes sense of disconnected events, cognitive dissonance makes it painful to abandon that framework even when contrary evidence appears. The question asked of Stephen Miller whether the president had been briefed on 3I Atlas on national television is significant. It signals elevation. Objects that warrant presidential briefings are objects of strategic importance. The fact that the question was public, not leaked, means someone in the media considered it legitimate to ask. That shifts 3I Atlas from astronomical curiosity to potential policy issue. And once something becomes a policy issue, information flow changes. Decisions get made about what to release, when, and to whom. This isn't necessarily sinister. It's how governments operate when dealing with potentially disruptive information. The calculus involves weighing public's right to know against potential for panic, economic disruption, or social instability. But from the public's perspective, this calculus looks like concealment. And once trust erodes, it doesn't matter if subsequent explanations are truthful. The damage is done.
Every delay, every routine maintenance, every technical difficulty becomes evidence of the cover-up. Social media and distributed cognition. Social media has created a new phenomenon, distributed cognitive processing. The 3I Atlas subreddit, which barely existed in July, now has thousands of active members. They're sharing observations, analyzing images, dissecting every statement from officials, constructing elaborate theories. Some of it is insightful, some of it is noise. But collectively, it represents the crowd trying to make sense of incomplete information. This is valuable because sometimes crowdsourced analysis catches things experts miss. Astrophotographer Simeon Schmaus, processing Perseverance rover images and spotting 3I Atlas before any official release is an example. The crowd has resources, time, and motivation that individual researchers don't. They're not constrained by institutional review processes or publication timelines. They can work fast, share freely, and explore unconventional hypotheses. But it's also dangerous because without editorial filters, misinformation spreads as fast as accurate information, sometimes faster. The Fibonacci pulse claim by David Sarita went viral.
It exists now in a state where it's neither confirmed nor debunked. People who want it to be true cite it. People who think it's nonsense ignore it. And the truth remains unclear. The split between believers and skeptics isn't random. Research in cognitive psychology shows belief in anomalous phenomena correlates with certain personality traits and cognitive styles. People high in openness to experience are more likely to entertain unconventional ideas. People high in pattern recognition are more likely to see connections others miss, but also more likely to see connections that aren't there. The need for cognitive closure. The desire to have definitive answers rather than live with ambiguity drives people toward whichever explanation feels most satisfying. Either this is definitely a comet, or this is definitely an alien probe. The uncomfortable middle ground, I don't know but I'm paying attention, is cognitively exhausting to maintain. Scientists, contrary to the stereotype of pure rationality, are human and subject to the same biases. Once you've publicly stated a position, cognitive dissonance makes it uncomfortable to change that position even when new evidence appears. Avi Loeb is on record suggesting 3I Atlas could be artificial. His critics are on record dismissing that as sensationalism. Both sides now have reputational stakes. If Loeb is right, his critics look foolish. If he's wrong, he's confirmed as a fringe figure in the eyes of many. This dynamic makes objective evaluation harder because egos are involved. The ideal scientific process form hypothesis test update beliefs. Based on evidence gets tangled with human psychology. We defend our positions not just because we think they're correct, but because changing our minds publicly feels like admitting failure. Living in uncertainty. The cognitive load of living in uncertainty is exhausting. Humans crave resolution. We want answers. The brain expends significant energy maintaining ambiguous states. That's why people gravitate toward definitive narratives, even false ones. A wrong answer that provides closure feels better neurologically than no answer at all. This is why conspiracy theories are comforting in a perverse way. They provide explanatory frameworks. Everything makes sense if you accept the premise. The alternative that the universe is chaotic, that most events are random, that we understand very little, is harder to accept. It requires tolerating ambiguity, and ambiguity feels unsafe. Preparation for first contact, if that's what this is building toward, requires psychological readiness as much as technological readiness. If an extraterrestrial intelligence were revealed tomorrow, the immediate questions wouldn't be about propulsion systems or communication protocols. They'd be about meaning. What does this mean for humanity's place in the cosmos? What does it mean for religion? What does it mean for our future? These are existential questions, and they don't have easy answers. Different cultures, different belief systems would respond differently. Some would see it as fulfillment of prophecy, others as threat, others still as opportunity. The reaction patterns during COVID-19 offer a preview. Faced with a novel threat, the public split into factions, those who trusted official guidance, those who thought it was overblown, those who thought it was a conspiracy. Information warfare, competing narratives, erosion of shared reality. If 3I Atlas turns out to be more than a comet, expect the same dynamics but amplified, because this time it's not a terrestrial virus. It's something from beyond which carries symbolic weight. Pandemics don't. The mental health implications are under-discussed. If humanity learns it's not alone, that we're possibly being observed or have been observed, the psychological impact would be profound. For some, it would be liberating confirmation that the universe is alive and we're part of something larger. For others, it would be terrifying loss of agency, vulnerability, the realization that we're not in control. Anxiety, depression, existential dread, these would spike. Suicide rates might increase among those who can't integrate the new reality. Or conversely, meaning might increase, purpose might increase, if people interpreted contact as a call to action, to improve, to prepare, to prove ourselves worthy. Therapy frameworks for processing existential disruption exist but aren't widely known. Terror management theory. The psychological discipline studying how humans cope with mortality awareness would be relevant. If 3i Atlas represents contact, it also represents a kind of death, the death of human centrality, the death of the worldview where we're unique and special. Mourning that loss while adapting to a new reality is a process, and not everyone will navigate it successfully. Support systems, counseling, community, these become critical. The fact that these discussions are happening now, preemptively, is itself interesting. We're rehearsing for an outcome that may not occur. 3i Atlas might fade away just another comet, and all this psychological preparation will have been for nothing. Or not for nothing, because the exercise of thinking through how we'd respond, what it would mean, what we'd do, that's valuable regardless. It reveals our assumptions, our fears, our hopes. It forces us to confront questions we normally avoid. What is humanity? What is consciousness? What is our role in the universe? Those questions don't require aliens to answer, but aliens make them urgent in a way philosophy doesn't. Whether 3i Atlas is a comet or a probe, natural or artificial, the conversation it's generated has already changed us. We've spent months wondering, speculating, hoping, fearing. We've formed communities around shared curiosity. We've argued and researched and stayed up late refreshing forums for updates. That collective experience, the waiting, the uncertainty, the shared attention, is itself significant. It's a preview of how we'd handle actual contact. And based on what we're seeing, the answer is not great but not hopeless either. We're messy, biased, prone to both credulity and excessive skepticism. But we're also curious, adaptable, and capable of holding multiple perspectives simultaneously when we try.
In December, when 3i Atlas emerges, we'll have our answer. Or at least the next piece of the answer, and whatever we find, comet or probe, natural or artificial, we'll have learned something about ourselves in the process of looking.
So where does this leave us here in late October 2025, waiting for December's reveal? We have an object from another star system displaying anomalies that don't quite fit any category. We have alleged communications in the mathematical language of nature itself. We have suspicious timing, data gaps, institutional silence. We have scientists divided, the public fascinated, and 6 weeks of darkness where anything could happen. What's remarkable isn't just the object, it's us, our response to it. The way we oscillate between wonder and skepticism, hope and fear. The way some of us see clear evidence of intelligence, while others see obvious natural processes. The way this cosmic visitor has become a Rorschach test for humanity's readiness to confront its assumptions. In the end, 3i Atlas might be the most ordinary interstellar comet, strange only because we've seen so few. Or it might be the opening act of the most significant chapter in human history.
We won't know which until it emerges from behind the sun, until telescopes capture it in the clear December sky, until we see whether it's where we expect it to be, or whether it's done something during those hidden weeks that changes everything.
But here's what I find beautiful about this moment. We're all waiting together. Amateur astronomers and Harvard professors, believers and skeptics, all staring at the same patch of sky, wondering the same questions. That collective curiosity, that shared mystery, maybe that's the real gift 3i Atlas has brought. The universe speaks rarely, and when it does, its voice is subtle. A pulse of radio waves in 1977, a mathematical sequence in 2025, or perhaps just the patient drift of ancient ice through the void. We're straining to hear, to understand, to know whether anyone is speaking back to us through the cosmic darkness. December will come. We'll point our telescopes, we'll gather our data, we'll update our models and our beliefs. And whether we find a comet or something more will be different for having looked, for having wondered, for having taken the universe seriously enough to ask if it might be speaking to us in Fibonacci numbers and golden ratios. The object behind the sun isn't just carrying ice and rock and maybe microbes, it's carrying a question. Are you ready to know? Are you prepared for the answer, whatever it turns out to be? Can you hold the possibility of cosmic companionship alongside the probability of cosmic solitude? And perhaps the only honest answer any of us can give right now is this: we're about to find out. Sleep well tonight if you can. Dream of spirals and numbers of ancient ice and distant stars. Dream of the moment when certainty replaces speculation, when the object emerges and we finally see what's been hidden in the solar glare. And when you wake, the universe will still be mysterious. 3i Atlas will still be out there doing whatever it's doing, and we'll still be here watching and wondering, hoping that someday, maybe December, maybe later, the stars will finally speak in a language we can't deny. If 3i Atlas does maneuver in December, if it shows clear signs of artificial origin, if humanity wakes up one morning to the confirmation that we're not alone, will you remember this as the moment when everything seemed possible but nothing was yet certain? The last quiet breath before the universe exhaled its answer. Will you remember wondering, here in the dark before dawn, whether we were about to meet our cosmic neighbors or simply ourselves, reflected in the ancient ice of a wandering comet? Keep watching the sky, keep questioning, keep your mind open but your thinking critical. Whether 3i Atlas is a cosmic coincidence or cosmic communication, the next chapter begins in December, and you'll be there to witness it. Until then, stay curious. The universe rewards those who pay attention.